Hello everyone. Hello. Yes. So recall the last lecture where we have covered the physical layer as far as SPPU syllabus for this ITCCN is concerned. Last time we covered a physical layer in which we saw the guided and unguided media. The physical layer is handling all those voltages, bit stream, raw data bits at a physical layer. Also a guided and unguided media is nothing but wired or wireless media. So for wired media, we have seen the different cables like coaxial, UTP, STP, fiber optic cable, and as far as wireless networking is concerned, which is being used for Bluetooth, Zigbee, Wi-Fi, and all other different cellular technologies like 1G, 2G, 3G, 4G, and so on, WiMAX. For that, you require unguided media. So different RF spectrum and different frequencies, different bands, which are being used for wireless communication in the form of unguided media we have seen in detail. Now today we will deal with the second layer. Okay, as I told you, whenever you are talking about networking, you have to think about ISO-SI reference model. Whenever you want to discuss the network theoretically, you have to go for ISO-SI reference model. And whenever you want to discuss the network or whenever you want to implement the network practically, then you have to go for TCP/IP. So just try to recall a 7-layer ISO-SI reference model. So application layer, physical layer, and session layer of ISO-SI reference model, they are combined to have an application layer of TCP/IP, transport layer as it is, network layer as it is, and lower layers, that is data link layer and physical layer. They are equivalent to data link layer and physical layer of TCP/IP. Sometimes in TCP/IP, it is known as host to network layer or lower layers. So now the point has come to discuss the computer network practically. So let us represent the network system practically. So here, let us say this is one system and this is another system. One system, let us say laptop system, want to communicate to another PC or laptop. Okay, so as I told you, whenever I'm talking about networking or data communication, it is a communication between two systems where one you can call it as a client and another you can call it as a server. So client is using the service and server is providing the service. So let us talk about these two systems, this 5-layer TCP/IP model and this 5-layer TCP/IP model is representing these two systems. So let us say we have already seen that, let us say at application layer 10 GB of data is there and you want to transfer this 10 GB of data to another system. So application layer to application layer, okay, you want the data transfer. So last time only I told you that there is no provision of transferring the data from application layer to application layer directly. Whenever you are talking about this system, this application layer data, by adding the various headers at a different layer, it is coming down. So let us say a 10 GB data is there, a data transfer you want. So that data, a part of that data is taken. Okay, transport layer. Okay, TCP protocol is there at a transport layer or UDP protocol is there. So one of them right now we will consider. Let us say it is a TCP protocol. It is a limitation of a TCP protocol to take 64 KB data from application layer and send it to network layer. This is a built-in limitation of IP version 4. So TCP is the protocol working at a transport layer of TCP/IP protocol. So this TCP, that transport layer, can take maximum 64 KB of data, that is called as TCP segment, and then it can send it to network layer. So first of all, just try to recall that at application layer, it is called as message. When you come down to transport layer, it is known as TCP segment. Whenever you come down, it is known as IP datagram or packet at the network layer. And when you come down to a data link layer, it is known as frame. And whenever you come down to a physical layer, it is known as bit stream or raw data bits. So at application layer, it is known as message. Transport layer, it is segment. Network layer, it is datagram. Data link layer, it is frame. And at a physical layer, it is known as bit stream or raw data bits. So now try to understand what is my target. My target is to have a data communication between two systems. So let us say this system is represented by 5-layer model, and this system, another system, is represented by 5-layer model. 10 GB data is there. So it is a whenever this 10 GB data is available at application layer, when it comes down to transport layer, just now I told you there is a limitation of a transport layer TCP protocol to take 64 KB data from this 10 GB and give it to network layer. Again, it is a limitation of IP protocol, which is working at the internet layer called as network layer, to take only 64 KB data maximum coming from transport layer and give it to data link layer. So try to understand transport layer and network layer of TCP/IP protocol has a limitation to process only 64 KB data. This IP version 4 header and transport TCP header will be covered in next year computer networks and security subject. But right now keep this in your mind that though the data of 10 GB is available at application layer and you want to send this data by networking process to another system, you have to keep this in your mind that this 10 GB data, when it comes down to transport layer, the limitation of a transport layer TCP protocol to take only 64 KB maximum data and give it to network layer. Network layer IP protocol has again have a maximum limitation of 64 KB data and give it to data link layer. The limitation of the data link layer is to process only 1.5 KB. See this 1.5 KB, 64 KB, they are the payloads of every layer. So whenever I'm talking about data link layer, it is divided into part. Upper part, lower logic link control, and the lower part is nothing but a media access control. Upper part LLC, lower part MAC. LLC deals with framing flow control, data error detection and correction. And lower part deals with media access control. Okay. So what is important thing is data link layer. At a data link layer, as I told you, lower part is nothing but Ethernet. We are using full duplexed switch Ethernet, which works on the principle of IEEE 802.3 IEEE standards and CSMA CD protocol. So the limitation of that Ethernet frame size is 1.5 KB, 1500 bytes only. So though 64 KB data is available, data link layer, MAC technology at a lower layer doesn't have provision to go for more than 1.5 KB data. So this 1.5 KB data is nothing but a frame of 1.5 KB, and when it comes down to physical layer, it is divided into a raw data bits, that is 1010101010. Likewise, raw data bits is available, and this raw data bits or bit stream is then transmitted on a physical layer. So physical layer media, last time only we have seen, it may be a guided media or it may be a unguided media. So it may be a wired networking or it may be a wireless networking. Thus, the data which is available in the form of 101010 is taken and is reaching to another system. When it reaches to another system, the function of this data link layer is to break this bit stream into frames. So this raw data bits or bit stream is converted into frames. Then frames converted into packet, and packet converted into transport layer. Then this transport layer segment or this datagram converted into segment at a transport layer, and the segment again coming at application layer, it becomes a message and a pure data. So 10 GB of data is there at one system. When it comes to transport layer, it becomes segment, then datagram, frame, bit stream, physical layer, bit stream, frame, IP datagram, segment, message, original data of 10 GB. Please keep this in your mind. Okay. So after explaining these fundamentals, what is the conclusion? The conclusion is at a data link layer, you have two layers, LLC plus MAC. LLC, logic link control, and lower part of this data link layer is media access control. This media access control, MAC technology, is nothing but full duplexed switch Ethernet. Other technologies are token ring, token bus, etc. But whenever I'm talking about full duplex switch Ethernet, it is 1500 bytes of frame size can be transmitted, can be accepted. So though 64 KB data is available from network layer, only 1.5 KB data will be considered, and then it is divided into bit stream. So though you are having 10 GB of data or 100 GB of data or 1000 GB of data, using TCP/IP protocol, if you really want to transmit or if you really want to send it from one end to another end, you have to go through this channel, and this TCP/IP channel, the bottleneck is formed at every layer. The bottleneck which allowed 64 KB of data at TCP layer or transport layer, it forms another bottleneck at a network layer which allows only 64 KB data. And when you come down to the data link layer, the greatest bottleneck or the main bottleneck in this TCP/IP protocol stack is formed at a data link layer, and which has limitation of 1500 bytes only. So whatever may be the data available, only 1500 bytes data will be taken by data link layer, and accordingly it is proceeded. And when this buffer is free, when the buffer is free, then it will take another 1500 bytes. Then it transmits another 1500 byte. It is taken from that, and then it is transmitted. Same way over here. If the data bit stream is coming, the main function of this LLC layer at a data link layer is to break the bit stream into frames. So the frames are available. 1.5 KB frames are collected. Then one packet of 64 KB is prepared. Once this is prepared, it is given to the transport layer. So it is maximum allowed is 64 KB. Likewise, it gives this data to the application layer. So one by one, the data is available at another end, and then 10 GB data is transmitted through these different layers, and 10 GB data is received at another end. So this is what the data combination. So please keep this in your mind, that application layer to application layer, direct data communication is not possible. This application layer data, whatever data is there, it has to come down to transport layer, network layer, data link layer, physical layer, from physical layer, data link layer, internet layer, transport layer, and up to application layer, with the limitations of maximum segment size or packet size or frame size, and accordingly the different bottlenecks are formed. That's why TCP/IP becomes slower. Otherwise this 10 GB data would have been directly transmitted to another system with no bottleneck, without any obstacle. Please keep this in your mind. This is very important. Now one more thing I would like to tell you, in next year you are going to study IP version 6. But what is the limitation that in IP version 6, as I told you, instead of 64 KB datagram size, they have a datagram size of almost 4 GB. What is the meaning of that? At application layer, if 10 GB data is you want to transmit using IPv6, let us say that jumbogram of 4 GB is coming. So within 2 or 3 packets, it can be directly transmitted to another system. But this is not happening. Why? Lower layer, that is data link layer, MAC technology, it's still Ethernet. So it has a payload of only 1.5 KB till the technology has come in 2020. What's the main problem? The main problem is Ethernet. The maximum payload is 1500 bytes only. So whatever may be the IP version you are using, if it is IPv4, maximum 64 KB data you can take and give it for frame for data link layer. And if you are using IPv6, though 4 GB of jumbogram is allowed in IPv6, when it comes down to data link layer, the maximum frame size you can have is of 1.5 KB only. And accordingly, the data is transmitted from one end, the end received at another end. So what's a function of data link layer? Please keep this in your, what's a function of data link layer? Packets are coming, so packet are coming divided into frame, converted into frame, and the frame is converted into bit stream. So this is the first function of data link layer, that the data coming from network layer in packets you have to convert into frames, and frames to raw data bit stream, raw data bits, that's the bit stream. This is the first function, upper layer to lower layer. And what is second function? If the data is coming like this, data bit stream, breaking bit stream into frames. So bit stream to frame conversion and frame conversion to packet conversion. Okay. The frames are given to network layer. So what is important thing is stream to frames, and these frames are converted into packets at a network layer. And here a network layer, the packets are there. They're converted into frames and frames converted into bit stream. So that is what the intermediate function of this data link layer or intermediate layer. So now one by one we will see. Now you have understood that if two systems are there, how 10 GB of data is being transmitted from one end to another end with the help of this data, segments, datagram, frame, raw bits or bit stream. And when it comes to another end, raw data bits or bit stream, then converted into frames, then IP datagram, then TCP segment, and finally data of 10 GB. Next. So as I told you, this LLC, okay, this data link layer at both ends, it is divided into two parts, LLC, and this lower part is nothing but media access control, which will be covered in next year. So what is this LLC? The first part that we are going to see today. So what are the function of LLC? LLC deals with framing, flow control, and data error detection and control. Framing, flow control, data error detection and control. So what is this framing? What is this framing? Framing, breaking bit strings into frame, is known as framing. What is the meaning of this? As I told you, when the data is transmitted from this system in the terms of or in the form of bit stream, when it comes to physical layer, okay, what is the function of LLC layer of this data link layer? Converting or breaking this continuous bit stream into frames is known as framing. That is what indicated over here. So whenever you are coming from physical layer to data link layer, this process is called as framing. So what are the different framing techniques? Now there are three types of framing techniques. One, character count. Number two, fixed size framing. Number three, variable size framing. So what is this character count and fixed size framing? So character count, right now nobody is using because of probability of error propagation is 90%. So this is a character count. Number two, fixed size framing. It is not there in your syllabus, but next year it is there in your syllabus. That is fixed size framing. It is using ATM networks, that is asynchronous transfer mode. A separate unit is there on asynchronous transfer mode. So right now talking about ATM will be beyond the scope of this syllabus. So right now just keep in your mind that data link layer is divided into two parts, LLC and MAC. LLC, that is logic link control, deals with these three functions: framing, flow control, data error detection and correction. Framing, as I told you, there are three methods: character count, fixed size framing and variable size framing. Character count is not used. Fixed size framing is used in ATM networks. But as far as your syllabus is concerned, variable size framing is mentioned in your SPPU syllabus. So variable size framing is divided into two parts: character oriented protocol and bit oriented protocol. Character oriented protocol is nothing but byte stuffing technique, and another is bit oriented protocol known as bit stuffing. So have you understood this? Once again, I'm repeating this fast. Data link layer is divided into two parts, LLC and MAC. LLC. deals with logic link control. The function of LLC or LLC deals with framing, flow control, data error detection and correction. Framing, there are three techniques: character count, fixed size framing, which is used in ATM networks, and third is variable size framing. What is framing? Whatever data coming from the physical layer, it is in the form of bit stream. So breaking that bit stream into frames is nothing but framing. So character count, fixed size framing, it is not there in your syllabus. Variable size framing is there in your syllabus, and it is divided into two parts: character oriented protocol and bit oriented protocol. Character oriented protocol uses byte stuffing technique, and bit oriented protocol uses bit stuffing technique. So these two techniques we are going to see as far as framing is concerned, as far as your syllabus. So now all of you give attention. In computer network, data representation at data link layer or network layer and transport layer, respectively known as segment, packet, and frames. Just now we saw data link layer, it is called as frame. Network layer, it is known as packet. And for transport layer, it is known as segment. And this entire data of, let us say, this 10 GB, just now I told you, okay, is represented as pure data and a control information. This control information is also known as header. Sometimes it is represented like data and control information, that is header, and sometimes data and control information at left and right side of this data, that is called as header and trailer. So data information plus control information, that is header, data information plus control information before and after, that is called as header and trailer. So these are the two ways of representing the data: actual packet or actual segment or actual data to be communicated over a network. Pure data plus control information, pure data plus control information. Now, as I told you that framing, three techniques are there: character count, fixed size framing, and variable size framing. In variable size framing, I told you that it is there in your syllabus. Two techniques are there. One is character stuffing. It is also known as byte stuffing. And second technique is bit stuffing. Okay, so let us start with this character stuffing. So just now I told you that a data over a network is to be transmitted in a specific format. What is that format? First is a data and a control information. So control information is available at the left side of pure data, and control information is available at the right side of data. So this is what the pure data, that is called as characters or actual data to be transmitted over a network. Okay, so the data may be a audio, video, graphs, text, and so on. Okay, so let us say this control information. Left side control information is having flag and header. What is flag? Flag indicates a start of frame. A specific bit pattern is there, 0 1 1 1 1 1 0, like that. Okay, so this indicates a start of data or start of frame. The same flag is there at the end, which indicates end of frame. So for synchronizing transmitter and receiver for data communication initiation and termination, this type of flags are very important. Next, header. Header at the left side indicates a control information which is required to send this pure data plus source address and destination address. As I told you, system 1 want to communicate with system 2 always. In this two system, you have a data to be transferred. So this header information indicates a control information, that is source address or destination address. So this is flag, this is header, it's a pure data flag, and this is trailer. What is this trailer? Trailer is again a control information plus data error detection and correction. So this is what the function of trailer. So what is important thing is, pure data, left side control information, right side control information, in which flag is used to synchronize transmitter and receiver, and this header control information plus source address and destination address, whereas trailer consists of data error detection correction and some control bit information. Now, such type of data, let us say a frame, is being transferred from one end to another end. But the problem can occur. Two problems we are going to discuss in this scenario. The first problem is, let us say a flag, as I told you, is used to synchronize trans receiver. In pure data itself, a flag analogous data is coming. A flag analogous, this is the flag. A flag analogous data is coming in the data, and when it is transmitted, so receiver will be in confusion. The receiver will get confused whether it is flag or whether it is flag analogous data. So please read this. In data field, if flag analogous data appears, receiver won't be able to distinguish between a flag and flag analogous data. So such type of problem can occur. So what is the solution? What is the remedy? The remedy is you have to stuff a ESC character. ESC is nothing but a ASCII character of value 1B hex. So what is happening? If such type of frame is being transmitted and flag analogous data is coming in a pure data field, you have to stuff a ESC character whose value is 1B hex. So stuff at the time of transmission and at a receiver end. The moment receiver comes to know that ESC value, 1B hex value is available, it will destuff it. So stuffing of ESC at a receiver end, ESC will be destuffed. So have you understood this problem? That if flag analogous data is coming in a pure field or pure data field, the receiver will get confused. So what is flag and what is flag analogous data? So what is the remedy? The moment transmitter understand that the flag analogous data is to be transmitted, it stuffs ESC character of having 1B hex value, and then it is transmitted. So receiver automatically, when it get that information, it understand that ESC character is there. So it will understand that ESC is the stuffed byte. So it will destuff it. And accordingly, at a receiver end, if you see, at a receiver end, if you see, this stuffed ESC is destuffed and original data is available. So this is the problem and the solution over it. Now next, second problem. What is the second problem? Second problem is like this. Okay, let us say now flag analogous data is coming in a pure data field. So you have to stuff ESC and destuff at a receiver end. That you have understood. But let us say if ESC analogous data is there, then what is to be done? So if ESC analogous data is there, you have to stuff one more ESC. So two ESCs you have to see. So ESC analogous data is there, but it is not ESC. So you have to stuff one more ESC. So transmitter stuffs this ESC, and at a receiver end, this ESC is again destuffed. So original data will be recorded. So whether it is flag analogous data is coming in a data field or ESC analogous data is coming in the field, we have solution to both. But what is happening with this type of communication? Stuffing ESC when flag analogous data is coming, stuffing another ESC when ESC analogous data is coming. So what is happening? These are the control information. Control information is more, and because of which overhead increases, and more overhead reduces efficiency. So it is unending, cumulative, and hence not used nowadays. So character stuffing technique, okay, the control information which is to be added is more, okay. Data is constant, but if analogous data, that is flag analogous data and ESC analogous data is coming, so you have to stuff this extra ESCs and destuff at a receiver. Because of this, efficiency decreases. So this is the second problem that we have seen. And nowadays also this byte stuffing or byte oriented protocol or byte stuffing or character stuffing technique is rarely used. So what technique is used nowadays? The technique which is used nowadays, it's somewhat different, and this technique is known as bit stuffing So we will see what is this bit stuffing. See this, once again I am telling you, this is the pure data to be transmitted. Okay, this is header, this is trailer, this is flag, and this is another flag. Okay, to synchronize transmitter and receiver, you use this flag information. Okay, so flag 0, 1, 1, 1, 1, 1, 1. Okay, so almost 3 plus 3, 6 times of ones are there. So if such type of thing is there, so flag is to synchronize transmitter and receiver. Header, as I told you, header and trailer, a control information, source address, destination address, and source address, destination address, and control information is there in a header. And as far as trailer is concerned, so what is the information? The trailer has a control information plus data error detection and correction bits. Okay, so that is what the trailer. So now what is happening? Flag analogous data is available. It is in a pure data. So what is the meaning? Here 6 ones are there. If 5 ones, consecutive ones are observed by transmitter, it will stuff a 0. So there will be a break of consecutive ones. It is here also 1, 1, 1, 1, 1. 5 consecutive ones are there. So the moment transmitter understand 5 consecutive ones are there. So what is the rule? The rule is to add a 0 bit. So zero stuffed at the time of transmission. So these are the extra zeros which are stuffed at the time of transmission. So this is called as bit stuffing. Initial example in this previous, what we saw character stuffing. For flag analogous data, ESC you have to, for flag analogous data, you have to stuff ESC. And second problem that we have seen, that for ESC analogous data, again you have to stuff ESC. This is called as character stuffing. Bit stuffing, what is happening? Instead of that entire character, 0 is stuffed when you find consecutive ones. This is the rule written over here. Bit stuffing is the process of adding one extra 0 whenever 5 consecutive ones follow a 0 in the data, so that the receiver does not make mistake the pattern. What is pattern? 0, 1, 1, 1, 1, 1, 0 for a flag. Please keep this thing in your mind. Okay, so what is happening? If consecutive 5 ones are available, transmitter itself stuffs a 0 bit. And here also, transmitter stuffs the 0 bit. And at a receiver end, okay, when the entire data, that is flag, control information, header, trailer, along with pure data, and this pure data, because of these 5 consecutive ones, this 0 stuffed bit data is there. It is removed, it is destuffed. So these zeros are removed, and finally the data which was original, this data is available over here, and it will be delivered, and it will be received by receiver, and efficiency is found almost 100% in this type of communication. So please try to understand now what we have covered. So I'll just scroll this within 2 minutes, and again we will go forward. So first of all, what we saw what are the different layers. Okay, the data link layer is divided into two parts, LLC and MAC. LLC, it is dealing with framing, flow control, data error detection and correction. So framing, whatever raw data bits or bit stream is there, it has to be broken into the frames. So different techniques are there. They are character count, fixed size framing, variable size framing, character count, and fixed size framing, that is used in ATM networks. It's not there in your syllabus. Third technique is variable size framing. It is mentioned in your syllabus, where there are two types used: character oriented protocol, bit oriented protocol. So byte stuffing and bit stuffing, these are the two techniques used. So as I told you, the format for data to be communicated over the network, there are two types. One is a data, pure data, and a control information known as header, or sometimes a data and a control information before and after this data, that is called as header and trailer. Okay, so accordingly we have seen character stuffing technique, that if flag analogous data is coming, ESC you have to stuff, okay, and you have to destuff it at a receiver end. Okay, so this is what the problem, this is the solution. Another problem, if ESC analogous data is coming, you have to stuff another ESC, and at another end ESC should be destuffed. So flag analogous data and ESC analogous data is going to be retained without any problem. So what is the problem with this? This ESC and ESC, the control information is being added more. That's why the efficiency reduces and it is unending cumulative and hence not used nowadays. So the technique which is used nowadays is a bit stuffing technique. So in bit stuffing technique, what is the rule? If five consecutive ones are coming, so you have to stuff a zero bit. Let us say five consecutive ones are coming, stuff this zero bit. Five consecutive ones are coming, stuff this zero bit. And when you transmit it and receive at a receiver end, automatically this stuffed bit zero will be removed, this stuffed zero bit will be removed, and the received data will be the transmitted one. So this type of bit stuffing technique, which is used in a bit oriented protocol, gives you 100% efficiency. So this is what the completion of logic link control framing techniques. Now another applications of this or the function of LLC is nothing but framing. We have seen now flow control, data error detection and correction. So in next session we will see a flow control, data error detection and correction. So now we will stop our discussion today here and we will meet in next session with flow control, data error detection and correction in data communication. Okay, thank you. Thank you very much for listening this session with the patients. If you have any doubt, you please ask me. Otherwise, we will close down this session. Please ask me if you have any query. Thank you. Then we will conclude the session. And if you have any query, you please mail me on a Google Classroom or you can send a message to my WhatsApp number I've already given to you. You can mail me also, and also you can communicate me on my mobile phone number if you have any doubt related to it. So I'll be there to help you for solving your queries. So thank you very much.